Okay, so it is just a little before 2:30, and time to show up. I'm showing up. I'm glad you showed up. I appreciate every single one of you. Do the little YouTube dance, like, comment, subscribe, all that happy horse shit, and let's shit in the box. You'll notice the lack of a beer. And the reason there's a lack of a beer is that what I am going to do today is going to take a very long time. And because it's going to take a very long time, I'm not going to make you watch the whole thing. But I'm also not going to be able to make one beer last through the whole thing, so I'm just not going to have one until it gets toward the end, and there's something that I can do about it. Now, what I'm going to do here is I'm going to fix some dumb shit that I did a couple of days ago. And what I did was I recompiled the Godot engine. And upon recompiling it, I recompiled down to the release version, down to the 4.7.1 release candidate. I went back to the 4.7 tag, and here's the problem. I had already opened my current project in 4.8. So now that I was back on 4.7, I could no longer open that project, because it's an incompatible version. So I've got to go. I've got to recompile back to 4.8. So the first thing that I'm going to do, I'm going to change to my repository. And the first thing that I'm going to do is I'm going to do a git pull from the origin, and I'm going back to the latest, which is the 4.8 dev version. It's going to grab everything. And after it's grabbed everything, wow, there's been a lot of stuff added in here. Yeah. Well, it's not so much added in. It's because I backed up to 4.7. So anyway, once this completes, once it's actually dragged everything down and gotten it off of the server, and I've got all of the source code, we're going to recompile it. And typically, what I do is I check and make sure that I've got the latest version of pip and the latest version of scons before I do that. Before I do the actual build, so I make sure that I'm using the latest stuff. Once we get started on the actual compile, which takes like 10 to 15 minutes usually, then I'm going to pause, and I'm not going to make you watch that go through. But when you get started on this, when you get started on like compiling everything, you got to have the Windows SDK, you got to have Visual Studio, or you got to have like a Minji W64 installation or the proper environment set up. You need the right version of Python. You need all of this stuff, and all of that is on the Godot website, compiling for Windows. It's very good. It's very well done. There's like a lot of stuff you get, like you got to get Angle, and you got to install various libraries and whatnot, and just follow the instructions. They're good instructions. I trust Remy. I trust Juan. I trust Ariel. They all do a very good job. It's in the process of compressing, and this takes a long time. We're getting there bit by bit by bit. $523.63. Ooh, this is riveting content here. There we go. Now it's writing the objects. God only knows how long that's going to take. Probably not that long. But yeah, this is pulling everything down to go from 4.7 to 4.8. And once that's all come down, we can start the actual process of building. And this is actually going to be like a real world thing. I'm going to show you like all of the steps, all of the things that I actually have to do to make this happen. Which is more than you think, and it doesn't put absolutely everything in there because it doesn't know all of the bits and pieces. But really, the reason I'm doing this is I want to take a look at the implementation of nodes in Godot. And I thought it might be instructive to actually see me do that and go through the process of, look at that. Oh, yeah. So we're done on that. Now we're going to go back. And we're going to start by upgrading pip. Now it's going to load Python into memory because I've rebooted. Okay, I've already got the latest version of pip. Now we're going to upgrade scons. Already satisfied. And because PowerShell saves your command history from execution to execution, I just have to back up through my command history and get the correct commands. So the first scons command is I'm compiling for Windows, and the target is the editor, and I'm using the mono module so I can use C#. And I'm going to whack enter on that, and it's going to get started. It's going to read the files, and it's going to start compiling the various files. It's using Visual Studio with this Windows SDK. It's got 12 CPU cores available, using 11, which platform it's building for. This is all the stuff that you can just kind of look at and make sure that it's doing the right thing. Windows x86-64 target editor. Yep, I'm cool with that. And then it'll start showing like percentages and compilation. Done reading, now it's building targets, and it's going to start from 0%, and it's going to start going through and building individual files. And it is at this point that I am going to pause because you don't need to watch this. This is just not that interesting and not that important. So I will be back momentarily. Okay, we are now at the 100% mark. So it's just finishing everything up. It's linking stuff, and then it'll be done, and we can move on to the next step. Because this is just the beginning. Once it's actually finished linking, the next thing that we need to do is we need to cut the Visual C++ project file so that we can browse the solution in Visual Studio. I want to look at what the node object is doing, which means I need to dig into the source code and I need to look at it. And this will also make it possible for me to debug it. So yeah. Now, theoretically, when you cut the Visual Studio project file, theoretically, you can use this to build from Visual Studio. I have never done this, and I don't trust it. I don't want to do that. I don't want to press the build button and have it build. So all I really want to do is just use this to view the source code and know that the source code that I'm looking at is the source code that I'm actually running. That's the important thing. And this build is actually going to finish fairly quickly. It's not going to take that long because all it's doing is building the project file. It's not really like compiling anything. Well, not at this point. It's compiling the project file, but I don't know whether you can do this before you've done the full build. I mean, I would think that theoretically you could just drop the Visual Studio project file and then open it in Visual Studio and press the build button. But again, I don't trust it. I don't do that. So because I don't trust it and because I don't do that, I don't know if it works. And I don't care. This is one of the things about software development that a lot of people don't talk about. There are a lot of questions that have answers, but I don't need the answers, so I don't care. I'm not going to get the answers to the questions because they're not important to me. Like, how do I build successfully from Visual Studio? Who the fuck cares? I'm never going to do that. Why would I do that? Why would I want to do that? This is taking longer than I remember it taking. I don't know why. But it'll finish, and it'll bring up the prompt. And when it brings up the prompt, then we have to move on to the next thing, which is building the export templates. And building the export templates takes about as long as building, there we go, regenerating the filters. And that'll be done after that's finished, which doesn't take very long. We're more than halfway through at this point. But generating the export templates, every game that you write in Godot basically bundles the Godot engine into it. So you can see here that we've got essentially the same SCONS command line, platform windows, module mono enabled is yes, but the target is now template debug. So we're creating the debug templates, and that will give us the export capability to pull those templates. This takes about as long and does about the same thing as the initial build. So because of that, we are again going to pause. And I'll be back in about 12 minutes, I guess. Okay, so now that's finished. And because that's finished, we're going to now go on. We are now going to do platform Windows target template release. We're going to build those. This is the exact same thing. Takes as long as it takes. Well, this only took like 4 minutes and 23 seconds. So I'm just going to go ahead and talk through this. Once we actually finish building all of the release templates, okay, it is at this point that we have to actually go into Godot and figure out where we're putting the templates. Now, I already know the answer to this, but essentially what you're going to do is you're going to start with your Explorer window, and you're going to go to well, it's already in my setup, but you're going to type %appdata% up in the location bar, and you're going to whack enter, and that's going to take you to the user, your username, app data roaming. And you're going to scroll down in this, and you're going to find Godot, which is right here. And you're going to open that up, and in all of this stuff, you have the export templates. And when you go into the export templates, this is where you're going to put the folder where your export templates go. But in order to know what the name of that folder is, you have to know exactly which version of Godot you're building. Now, I know which version of Godot I'm building. It's 4.8.dev.mono. However, I'm going to show you how you get that and where you find that, so you can do it yourself, and it will work no matter which version you're building. And once this is finished compiling here, once this is finished building, which will only take another couple of minutes, then we can fire up the, actually we can do that now. It's not necessary, we don't have to wait for this to finish. We just have to wait for it to finish before we actually copy them over. So I'm going to open the Godot game engine, which is already built, and I'm going to click over here on my project, and I'm going to click Edit. And it's going to open that on the wrong monitor, as usual. And I'm going to have to go over here and pull it down and drag it over here and bring it back to maximize. And what we're going to do is, if you look in Help About, it will tell you which version you've got. Okay, and this is a 4.8 Dev Mono custom build. But what you want to do is you want to go into Project, Export, and it will immediately give you errors because it is not finding the export template at the expected path. And that expected path right there, 4.8.dev.mono, that's where you need to put it. Now, it also says that it's looking for Windows Debug x86-64 and Windows Release x86-64, okay? But you will find that those are actually not the names of the files. In fact, I'm going to go look at the actual names for the files in a moment here. Once this actually completes, I will jump over into the Godot directory. Let's open up a new Explorer window here, and we will jump into my GitHub folder, and we'll come over here to Godot, and we'll jump into the bin directory. And you'll see the bin directory has like all of this stuff in it, okay? And you will find that the template debug and template release files, these do not have the names that we got out of that dialogue. That's not the names that are in the error messages. And because they're not the names that are in the error messages, what you need to do is you need to copy them over into the export directory and give them new names. And we are now finished building, and now that we're finished building, you can see here we've got the final release, the x86-64. So these are all where they're supposed to be, and because they're all where they're supposed to be, I can now come in here and I could say, okay, I will right-click and I will pick New Folder, and I will type 4.8.dev.mono. That's the folder we're looking for, and you'll see here I have this batch file called copytemplate.bat. Now, batch files are really, really easy. And that just copies them over, and I just drag them over there into the mono folder, and we're done. And at this point, we need to generate the glue for mono builds. This is kind of weird, but all we have to do here is we just go, we just run bin Godot Windows Editor. We run the version of the editor that we just compiled, and we say generate the glue files. And this happens very, very quickly. It generates all of that stuff. The Godot API sources were successfully generated. And it doesn't actually give you the prompt back, but the prompt is like there. This is a weirdness of that particular script. And now, this is a thing that nobody tells you and that I had to work out for myself. Because the assemblies that you build here because these assemblies are specifically matched to the version of Godot that you built, you must push them to a local NuGet source, because nobody else has this build you just made. This build you just made, nobody else has the exact build you just made. So nothing on any remote source run by anybody else has anything that matches this version. You have to push it to a low. Oh, well. You have to put Python at the beginning of this. Sorry. Sometimes I fuck things up, and then the error gets like preserved in my command history. And that has actually been in my command history for quite some time because I'm a fucking idiot and I keep executing it again. Anyway, once that's done, once that pushes to the NuGet source, and you can see here, I've got all my stuff in there. And if I now go in and open Godot, if I open Godot now, and I say, yeah, edit, and it comes up. When it comes up, I can go over here to the File menu. And when the Project menu, I go to Project, I go to Export, and I do not have any errors because it can find the desktop runtime. So that's no problem. That's done. And permission error on Godot Sharp. Oh, that's I got to do that again. I got the permission error because I was running Godot. And because I was running it, it had the file locked. So I couldn't push it to the NuGet source. Because I'm stupid and make bad decisions. Got to pay attention to things like this. Anyway, what was I going to say? Oh, yeah. There are some additional issues that I will run into when I actually open Visual Studio to work with this. But everything is now set up. Godot will work. Okay, the next thing that I need to worry about is I need to concern myself with the browsing of the source files in Visual Studio. And that won't be very long. There we go. Build succeeded. So now all of this is done. All of this is taken care of. That's a complete build. And it took, it is almost 2 minutes after 3. So about 40 minutes total. And only 22 minutes of the video, obviously. But at this point, I can close PowerShell. And I can open Visual Studio. And opening Visual Studio, I'll say continue without code because here it is, brand new, opened. Now, there is an issue in that the solution to the solution file for Godot has it has got the font choices in it. So here's the solution file right here, and it's got the font configuration in it, which means when I open it, one or more projects in the solution were not loaded. Okay, so what I have to do here, you see in the class view, the font is just tiny. I can't read this shit. But here in the Solution Explorer, we have a problem, and that problem is unable to read the project file. The expression .21 cannot be evaluated. What the fuck? Okay, so let's take a look at that. We'll double click it and it'll open up, and this is on line 15,284 of the project file. And this is a C-Link compile include excluded from build condition, active product item list. Exclude from build when we're not compiling for Android Java native. Oh, well, I don't care about that. And because I don't care about that, I can just delete that line. And now we've got this empty container and we can just delete that. Okay, so yeah, let's Let's reload that. Yeah, save. Unable to read the project file. Expression.21 cannot be evaluated. System string 21 not found. That's fine. This is on line 21,401. Android Java native sources configs. Yeah, I don't fucking care. I'm not compiling for Java. I'm not going to be compiling for Java. We're fine. Let's just go ahead and kill that and reload it. And now we have warning, the build tools for V143, Visual Studio 2022, cannot be found. Well, of course they can't, because I don't have Visual Studio 2022 installed. Install V143 to build using the V143 build tools. I don't care. I've already said I'm not going to build from the IDE, so this doesn't matter. I don't give a shit. But if I go to class view, I can't fucking read it. I do give a shit about that. So I'm going to go to project. Is it project? No. View, edit, build it, tools, options. Okay, so in tools, options, we're going to go to all settings, environment, and we're going to open up environment, and we're going to come down to fonts and colors. This is a legacy setting that hasn't been migrated yet. And we're going to open that up. Environment, fonts and colors, text editor, Cascadia Mono. Yeah, how about no? How about fixed sys? I like fixed sys. And now we're going to open that back up, and we're going to go show settings for environment, and the environment includes the, and you see here it's set to automatic. We don't want it set to automatic. I want to set that to fixed sys again. Well, let me set it to fixed sys. Huh. It will not let me use fixed sys. That's annoying. I wonder why it won't do that. Let's use up, fuck it, Calibri. Calibri will work. Set it to font size of 10. Okay, there we go. That works. Okay, so now I can actually browse the source code and sneeze. Okay, there we go. So I actually sneezed this time. So we are now sitting in our environment, and we have everything available. And it is at this point that I'm going to whack pause and I'm going to go get a beer. Right. Got me a beer. There we go. Okay, now I want to know how the node works. Why is there a new folder here? I don't want a new folder. Delete that. Okay, so Godot. Some people make the mistake when they get a brand new project. They go, well, let's just look at it and see how it works. Yeah, no. You're not going to be looking at it and seeing how it works. It's not, if you're working with a real project that's made by real people, looking at it and seeing how it works, not an option. Just not an option. Now what I want to know is I want to know how the node works. So I'm going to scroll down here and I'm going to find node CPP. Here we go. We've got node right here. This is the node class, and the node has a bunch of information on it. Okay. Now, what I'm interested in, what I want to know about is, I have got a concept. You know what? I'm actually going to have to open. I'm going to have to open my. I'm going to have to open my drawing program so that I can illustrate this and show you what it is that I'm thinking about here. This always takes a while. Let me flip over to my notices and see what it's notifying me of. Illustration, blah, blah, blah. Clip Studio profile. Ooh, your Clippy points are going to expire. Recommended for you. Submit your tips of the month. Yeah, no, I don't care. I don't care. None of that's important. So we're going to head back to home. And what we're looking for is this little thing up here. We're looking for that 5 to drop down to 4, 3, 2, 1. And then it's done. And once that finishes, then I can open draw. I don't have any pervy stuff up there, do I? I don't think I do. Anyway, so here we go. We'll close that, and I will just pop up a brand new. Oh, the hell is going on here? Something is not working. Dial mini. It looks like it should be working. So, oh, I'm just pressing the wrong button. I'm an idiot. I'm stupid and make bad decisions. Anyway, let's talk a little bit about what's going on here. This is a thing that I've done before. Historically, I have, let's come down here to the palette window. All right. So historically, what I've done is the Godot documentation says you do not need to worry about oh, no wonder it's using the airbrush. So you do not need to worry about object pooling because Godot is very, very fast at creating and deleting objects. Is it really? Is it really? Because here's the thing that I did once before. I had a game called Railgun. A Railgun was basically Breakout, and you had all of your bricks up at the top of the screen like so. But down at the bottom, instead of a paddle and a ball, you had a cannon. And you could rotate the cannon back and forth. And you could fire a ball out of the cannon. And that ball would behave just like the ball in Breakout. It would hit and break the bricks and all of that sort of thing. But you could only have one ball on the screen at a time at first. And what I wanted was, as you broke more blocks, you would have a multiplier that went up, and it would go up to ×2 and ×3 and ×4. And every time your multiplier went up, you would get another ball. So you would start with just a 1, and then you would get another and another and another. So what I did was, when you got it, as you got more balls that could be on the screen, okay, you started out, there was only one ball. And when you had another ball that you could fire, when your multiplier went up, I would create a brand new ball. Okay? And that ball would bounce around on the screen. And when that ball went off of the screen, okay, instead of deleting the ball and creating a new one the next time one was fired, what I did was I just set that ball off. I just turned it off. I said that ball's off. And when you fired a ball, what I did was I looked through each object in the pool until I found one that was off. And I said, I found one that's off. I'm going to turn it on. And when I turn it on, I'll just initialize it. I'll set the position and I'll set the velocity and everything will be fine. This worked fine. Okay? This worked absolutely fine. But there's a problem when you start dealing with something that you're going to have a lot of stuff pop up and go away. And as you create stuff, if you've got a lot of stuff that's going to appear and disappear over the course of the game, all right, you end up in a situation where you have to create an anticipated number of objects that you need, like you'd create 5 of them. And then when you run out of objects, when you go through your object pool, you go, I need an object out of the pool. You go down your list of objects in the pool, and when you get to the end of the object pool, you go, oh shit, I'm out of objects. I'd better create some more. But you never delete these objects. You just turn them off when you're done with them. When you're done with them, you turn them off, and when an object is turned off, the next time you need an object, you just go through and you go, is one of the objects turned off? Well, object number 8 is turned off. Oh, okay, so I'll use object number 8 then. And when object number 8 is done, then you turn it back off. You basically, instead of creating and deleting objects, essentially, because creating an object is very expensive in terms of computer time in most systems. Because creating the object is the hard part, the time-consuming part, you don't delete them. Because when it comes time to delete it, if you delete it, you're going to have to create another one. Deleting it is fast, but creating it is expensive. So because creating it is expensive, you want to avoid creating more objects as much as possible. You want to create objects when there are none, but instead of deleting objects when you're done with them, you just turn them off. And when you turn them off, what that means is the next time you need an object, instead of creating one, you iterate through the list and find one that's been turned off. Can you see the problem in this? Can you see the performance issue with it? The performance issue is this. Eventually, you get to a point where your list is so long that iterating through it takes longer than creating a new object. And when you hit that point, you can either flip a switch and go, fuck it, don't iterate, just create new objects. Or you just keep doing it like an idiot. Guess which one I did? Guess which one I chose? I'll just keep fucking iterating through it like an idiot. And it actually turned out, when I stress tested it, iterating through the list took longer than creating a new object when there were over 1,000 objects. And in Railgun, the number of objects you could have was constrained by your multiplier. And your multiplier was never higher than the number of bricks that you'd broken in a row. There were only like 300 bricks on screen. So your multiplier could never get higher than 300. And because your multiplier could never get higher than 300, it was always faster to iterate through the list. And because it was always faster to iterate through the list, you never got to that point where it was cheaper and a better choice to just create the object. Also, I did another stupid thing I shouldn't have done, which was the balls that you fired from your gun in Railgun were very heavyweight objects, and they really didn't need to be. That was really a good that was a good application for a particle system that would just iterate through the individual objects and process them, instead of having the actual algorithm of the game loop iterate through each individual ball and say, hey, let's context switch over to the ball and have the ball run a process function. It would have been better to iterate through them and to have it. It would have been a better choice. I am generally not a fan of manager classes, but in this particular case, this should have been a particle system with a number of particles that just processed the particles. That's the way it should have been implemented. I didn't implement it that way because, well, at the time I didn't really understand particle systems. I didn't understand the benefit of them. I didn't understand how you were supposed to be working with them, what you were supposed to be doing with them. And it's embarrassing to say that in retrospect, because when you've been a professional developer for 25 years and you don't know what a particle system is or why you would use one, that's fairly embarrassing. But normal. If you've never needed to use particle systems, Why would you know that? I know a lot about hash tables and binary trees. There are a vast number of programmers that never use hash tables and binary trees. It's like when I talk about using a top-down display to create the sorting algorithm for the tree, people just kind of stare at me like, what? The fuck is that? Well, you see, that's where you chop the tree into 3 pieces and rotate and reorganize. You're reorganizing the tree every time you search? Well, yeah. Why would you do that? Because then the tree's always sorted. And if you run millions of searches on the tree and most of your searches are for the same 12 items, those 12 items are up at the top of the tree and they're automatically sorted in order of frequency. So your most common searches are right there at the top. And then you can take that tree and you can hand it off to other things that don't use a top-down display. They just go through it and do a regular search. And then their search is much faster, but doesn't reorganize the tree. You can have parallel search algorithms. And that gives a lot of people the willies. They go, why do you have 2 different searches? Well, one of them's computationally expensive and the other one's computationally cheap. Why wouldn't you have 2 searches? That's wrong. It's just wrong. You don't do that. Sometimes when a thing seems like it's just wrong and you don't do that, the person you're talking to is much smarter than you. And sometimes they're just fucking stupid. It's impossible to tell which one is the case. You're just sitting here going, God, why would you do that? And they're going, because of reasons. And you don't know. There might be good reasons, there might be bad reasons. It's something nobody likes to admit. Very smart people look an awful lot like very stupid people, which unfortunately makes very stupid people look an awful lot like very smart people. And that's why Elon Musk is the richest man in the world. Anyway, the thing that I want to do at this point, the thing that I want to do here is, I've got this vast number of enemies. And what I want to do is, I want to create a whole bunch of enemies. And the idea here is that I have up here a spawner. And that spawner is going to have 2 lists underneath of it. And one of them is going to be active. These are enemies that are on the playing field and chasing the player. And over here, I want to have available. And these are going to be enemies that used to be on the playing field chasing the player, but they got killed. And instead of deleting them and thereby having to create a brand new enemy the next time I need one, I'm going to take the active enemy and I'm going to put it over here in the available list. Now, what this relies on is one fundamental concept. And that fundamental concept is that if I take the enemy and I say, no, you're not going to be in the active node, you're going to be in the available node, when I move that, is that fast enough to justify using it? Because here's kind of the algorithm that I'm thinking of. You've got all of these enemies in available, and what you've actually got is you've got available, and it's a node tree, okay? So it's got all of these child nodes. And when I say, okay, get the first child node in available, I don't have to iterate over the list because the first entry in the list is available. It's always available, and because it's always available, I can just grab the first one and I can put it over into active. I don't have to iterate through the list. And when I put it into active, well, actually the way that it works is the spawner will say, hey, available, give me an enemy. And the available will either go, I have one right here, and toss it up, or it will go, shit, I don't have any, I have to create one. And it will create a brand new one. And if it creates a brand new one, it will just send that one up. So spawner doesn't care. Spawner doesn't give a shit. Spawner just says, hey, available, give me an available enemy. Give me an available enemy. And the available, it goes, here's an enemy. And then the spawner will go, okay, let me initialize this enemy. I'll put all of the various properties on it that need to be there. And then I'll stick it in active. So the way that this is going to work from the available standpoint is the available node is going to give me an enemy, and it's either going to create a new enemy and hand it back, or it's going to take the first child, remove it from the tree, and hand it up to the spawner. Either way, when you ask available for an available node, okay, it's always going to hand back an available node that you can then stick down into active. So this is always going to work. It's never going to fail unless we have no available nodes and we're out of system memory and cannot create a new one. That's a fatal error. That is, your game needs to crash. So I'm okay with that being when it fails. If the game crashes when that happens, I mean, fucking hell, you don't even match the system. For God's sake, this game is going to be so light on system resources, it's fucking ridiculous. But anyway, this is the idea that I have. The problem is that I need to know that moving nodes around in the tree is fast and efficient. So I'm going to check that. And I'm going to check that right here. And the first thing I'm going to do is I'm going to look at the node's base types and make sure that the appropriate stuff is in there. Now, the object doesn't have a base type, okay? So when I look at object, okay, the object doesn't have a base type. So it's derived directly from object, which means there's nothing above it that's going to have an impact on the way that it works in the tree. So let me scroll down through here a little bit and go, okay, and some added little stuff here. I don't think any of that's really important. Child item iterator might be important. All of this is forced inline. We've got the operator pointer. We've got the okay. Children iterator. Force inline, operator equals, operator not equals. This is just a structure. Yeah. What is underscore pointer? Underscore PTR. Let's right click on that and we'll go peak definition. Node pointer pointer PTR equals null pointer. It's a private, oh, okay. So the children is just a node pointer array. If that's just a node pointer array, that okay, that's fairly simple. Okay, comparator is not going to be an issue. Comparator by index with physics priority, group name casting, blah blah blah. Unnamed enum, stuff like that is process mode name casing, empty flag, empty numeric. Okay, internal mode. All right, so let's look directly at node C++. Class node, public object. We're going to scroll on down here, and what I need to look at is set owner. Scroll down all the way. Look at all of this shit. Let's just real quick, let's take a look at something. I saw somebody the other day say, here's how I organize my 10,000 line game project. Now, oh, wait. This is node.h. This is a 953 line header file. The header file is 953 lines. And let's come down here to set owner. You see here that the set owner implementation is line 2,271. That's about halfway down. So this file is like 4,500 lines. 4,271, that's what it is. Okay, so we're going to come back over here. Okay, so set owner. We've got main thread guard. Error fail condition message is inside tree as it expands to error print error, error print. Okay, so that's all it is. That is just check whether we're in the right place, sanity check, and print an error. If data.owner, cleanup owner. What is cleanup owner? Data.owner. Data is the current node. Yeah. So data would be the current node. Let's do peak definition. So struct data, that's got all of the, okay, yeah. Yeah. Okay, this is all implemented in a struct, so that's going to be very lightweight and simple. Okay, yeah, because that's a struct. Yeah, that's very good. That's very good. I like that. Cleanup owner. I should take a look at cleanup owner. Peak definition. Fail if data owner is new. If data unique name and owner, release unique name and owner. Okay, it's freeing up memory. Data owner equals data owned erase. Okay. Data owner equals null pointer. Data owned erase. So cleanup owner literally clears problem. P owner, if not P owner return. Okay, so if we set the owner to null, that automatically takes it out of the tree, and it happens very quickly and very easily. It cleans up, so it does the cleanup, and then if the owner is null, it immediately returns. Okay, that's a good trapdoor, which means I can remove the node from the tree by doing set owner null. I can do set owner null, and away we go. Owner valid, P owner is ancestor of this. Is ancestor of. Peek it is ancestor of. Is ancestor of. Extract param or path. Extract param or fail, rather. Fail validation, required object P null. Okay, so this is a received pointer to the node. And we start by saying, okay, let's look at the parent and say, parent equals this, return this. P equals data parent, otherwise return false. Okay, so if there is no parent, it immediately returns false. Owner valid. Ancestor of this. P owner is ancestor of this. Okay. There's a double indirection of this here, which is causing me some little mental issues. Okay. P owner is ancestor of the new node. If the P is ancestor of, okay. So node equals null, while null, bool owner valid. Owner must be an ancestor in the tree. Ah, this is the wrong thing. This is the wrong thing to use for that. Set owner, we would use set owner null, but then we would use add child. Set owner won't let you do that. So what we need to do is add child on the, and that's not a problem. Let me check how add child works. Add child, required param node. Okay, so we would set owner null, and then we add child to, so we tell available to give us a node, and it does set owner null and hands that node to us. And then we take that node and we take that node and we properly initialize it, and then we call add child on active. So we add child to active. And we got a bunch of fail condition messages. And that all comes out. So this is just, all this is a huge error check. And then it ends with add child no check. So add child no check. Let's go see how that works. Add child no check. Okay, yeah. So we set the child, the name, the internal mode. We do it quickly without name validation, and that's, yeah, that's to save time, so it doesn't check stuff over and over and over again. Cam pushback is false. Internal mode front back disabled. And then we do the notifications at the end. Child gets notified, it gets set into the data tree, and okay, yeah. So that is actually very, very fast. Okay, all right. So I'm satisfied with that. I'm satisfied with this, and I am happy with the implications for the object pooling system. So So I like what I'm seeing here, and that's one of the things that I like about the Godot engine is that every time I look into it and I go, did they do a good job? They did. They did do a good job. I'm looking at it. I'm looking over the way that they implemented it, and I don't see anything stupid or extraneous or what the fuck are they thinking about here. It all makes sense. Remy and Juan and Ariel, they do a fantastic job. I'm very happy. That's one of the reasons I love Godot. Another reason is it's open source. I can look at the source and see what it's actually doing. I can build it myself, and it's scriptable in C#. That's really important to me. And unfortunately, I still need to learn GD script, which I really don't fucking want to do. But I do feel much better about the implementation of this for object pooling. So that'll be that for this video. Do the little YouTube dance, like, comment, subscribe, all that happy horse shit. And okay, bye.